showing this on the video.
What's going to be the topic of this one?
Quadratic equation, or completing the square.
Completing the square.
Yeah, we'll write on there. Okay, so we're going to start a new way of doing notes today. Cornell Notes, if you've done them before, or kind of like my own version. So at the top, I'm just going to, with my ruler, section that off. And then I'm going to make a straight line down the side, maybe like a little less of a third of the way through. And don't go all the way to the bottom, because at the very bottom I'm going to leave a little space, like maybe 3 or 4 lines for another area. So let me try to zoom out so you can see. Well, I try to do mine less than a third of the page, but I think I actually got a little more than a third. I won't zoom out any more than that. So down the left side, I'm going to leave that for like questions or main ideas, or even we can write the steps in there. Depends on what we're learning as to what we'll put over there. And then the target, which the target is what our goal is for learning that day. And if we have the target written in our notes, we know what we're supposed to learn. We can go back and read the target and say, did we actually learn that today? Okay. So today we're going to learn how do you solve, bless you, a quadratic equation by completing the square. And I'm giving these notes during first period on 11/8/18. Okay, so I'm going to save like this right hand side, the middle right hand side. That's where we're going to do the work. And on what we're starting with today is I'm writing down steps. Okay, so I'm just going to write down all the steps for completing the square. And then on the next example, when we actually have a problem to do, then I'll write the problem in the middle section. And then the goal is for you to go and write down the steps on the left-hand column, for you to figure out what the steps are in your own words and write them down in the left-hand column. But until we get used to that, then I'll lead you through that process. Okay? And down at the very bottom, we're going to use that for, maybe it's going to be questions you still have, something you don't understand. Might be to summarize what we did that day. Just depends on, it'll change all the time. Okay? So, we've been working on solving quadratic equations by factoring, right? But I told you that factoring does not always work, because when you solve a quadratic equation, you're figuring out where your parabola crosses the x-axis. Well, if it doesn't ever cross the x-axis, you're not going to be able to factor that problem. It doesn't mean there's not a solution, but you're not going to be able to factor it to find the solution. Okay? So factoring does not always work. A method that does always work is the completing the square method. Okay? Completing the square method. It's not the most fun method, but we have to know how to do it. All right? Okay, so this is going to be the steps for completing the square. And you want to make sure that you have these and you keep them handy, because it is kind of a long process. And sometimes you're going to get fractions and stuff in your problems, and we just got to work through it. All right? So our steps are, the first thing we're going to do is rewrite the equation in the form ax squared plus bx equals C. That's different from when we factored, because when we factor, we get our equation set equal to 0 and in standard form, right? When you're completing the square, you want your constant on the right side, and on the left side you want your quadratic first, and then your linear term. Another good thing for the left side of the notes is good for, if I say something but I don't write it down, but you think that's useful information to you, you can always jot it down in that left column as well, okay? Which you should do on any kind of notes anyway. Just because I don't write it doesn't mean you shouldn't. If it's something that's going to help you remember, do it. All right, step 2. Divide all terms of the equation by A. Divide all terms of the equation by A. If A is a number other than 1. Can y'all see that? Do I need to zoom? Yeah. Lights. I was just realizing I had a light left on. Hold on. Step 3. This step's got a lot of words. Complete the square. Sometimes you'll just see test questions and it will just say complete the square, okay? And it's just talking about this particular step. To complete the square, or we should say to do this, figure out what B divided by 2 quantity squared is, and add this number, no, B, like your B term, coefficient of x, B divided by 2 quantity squared. So figure out what that is and add this number to both sides of the equation. This will create a perfect square trinomial on the left side of the equation. So remember when we learned those special cases, one of the special cases was a difference of 2 squares, and the other one was a perfect square trinomial. And I said if you have a perfect square trinomial, there's a shortcut to factoring it, but a lot of you still wanted to use T-chart and divide and slide. And I said you need to know the shortcut because there's going to be a lesson down the road where we're going to have to factor the perfect square trinomial, and it's already enough steps as it is. I mean complete the square, I don't know what I just said. It's already enough steps as it is. You don't want to have to do the whole T-chart and divide and slide, okay? In this, when we use this method, your whole goal is to create a perfect square trinomial on the left side and then do the shortcut of factoring. Okay, so this is when it's going to be important. So if you don't remember how to factor a perfect square trinomial, which we'll review it again today, but that's going to be important, and that might be something you want to go back and write in the left-hand column of your notes. Okay? Step 4. Factor the perfect square trinomial using the shortcut method we learned previously. Factor the perfect square trinomial, I'm going to use PST, using the shortcut method we learned previously. Step 5. Running out of room. I'm not going to be able to skip lines anymore. Take the square root of both sides. Little star. Make sure to take the positive and negative square root of the right side. Step 6. Write 2 separate equations and solve each one for the variable. Write 2 separate equations and solve each one for the variable. So what I want you to do now, usually like I would bold something that I thought was important or highlight it along the way or underline it or whatever. I want you to read through your notes and see, is there anything that you find that's really important or that you think that should be highlighted to make sure that you remember to do that? So after we've done this several times, I'm just going to trust that you have gone and read through your notes and highlighted what you thought was important. But for now, like I'll go through with you and say, this is what I thought I would think is important. Rewrite the equation in the form ax squared plus bx equals c. Divide all terms of the equation. I think that's important. even on the other side of the equal sign. So like down the road, you might want to make yourself a little note on the margin. Like if you keep forgetting that, make a note. Remember to divide all numbers on both sides of the equal sign or something like that. Divide all terms of the equation by a if a is a number other than 1. Because obviously if a is 1 and you divide by 1, nothing's going to change, right? Step 3, complete the square. To do this, figure out what b divided by 2 quantity squared is and add this number to both sides of the equation. A lot of students only add it to the left side. They forget to add it to the right side as well. This will create a perfect square trinomial on the left side of the equation. Step 4, factor the perfect square trinomial using the shortcut method we learned previously. Step 5, take the square root of both sides. Make sure to take the positive and negative square root of the right side. Step 6, write 2 separate equations and solve each one for the variable. So maybe what I would write at the bottom of this one a little summary, and this would be something that I would want you to do on your own. I would just give you whatever I wanted you to put down there. But today, this was just steps so far. So I would say, why would you use this method? Okay. So maybe we could say this method will work to solve every quadratic equation. Bless you. Bless you. Factoring, bless you, does not always work. If it's factorable, it works, but not every problem's factorable. I'll put that in. Not every problem is factorable. So what we were discussing in our math department meeting yesterday was that even though we can take some really pretty notes and they're all color coordinated and such, if you don't use them, we might as well not have ever taken them. If you don't go back and read them, if you don't use them to help you with your homework, then and they just sit in your notebook and look pretty, then they were no use. It was just a waste of time for us to take the notes. So for you to remember stuff, it's really important that you go back and review them within 24 hours. Okay? That helps your memory level, that helps you retain information, and then a couple days later, go back and review them again. So I'm going to try to get better about making sure that you have your notes out and you're using them when you have questions. When you come to me, I'm going to say, show me in your notes where you read this. All right? Okay, so let's do an example. Now this seems like a lot of work. It kind of is, okay? This is not the quickest method that there is out there. But it is a necessary evil. Am I still writing this or have a question? All right, on the next page, I'll try to do this a little quicker, and I'm going to try to make my little left-hand column not so gigantic. Again, this is my very first time ever using Cornell Notes. I feel like everyone's just leaving me. Yeah, you can. I don't write on the back because up here kind of shows through and it looks crazy. And I would just make a bunch of these for you and make copies, but that would take so much paper for me to do this for all of our notes for all of my students. So we're still doing the same target, so I don't need to rewrite that each time. All right, so this is example 1. And we are going to solve by completing the square. I guess I could have written that in the top. So my problem is 3x squared minus 12x plus 6 equals 0. According to your notes, what's the first thing we should do? Exactly. Put it in ax squared plus bx equals c form. Sometimes it's already going to be like that. But if it's not, you got to put it that way, okay? So right now, it's an ax squared plus bx plus c equals 0. We want that constant moved to the other side, the quadratic term and the linear term. We want that to stay on the left side, okay? So I'm going to use the same color that I used in my notes for step 1. So I'll subtract 6 from both sides. And that leaves me with 3x squared minus 12x equals 0. Equals negative 6. Thanks. What's the next step? Divide all terms of the equation by a if a is a number other than 1. Is a number other than 1? Yes, so we need to divide all terms on both sides of the equation by 3. Both sides of the equation. That leaves me with x squared minus 4x equals negative 2. Step 3, complete the square. To do this, figure out what b divided by 2 is and add this number to both sides of the equation. Okay, so I kind of like do that over to the side. So we want to figure out what b divided by 2 quantity squared is. So what's my value for b right now? Not the original value for b, but negative 4, right? B is the coefficient of the linear term. So we want to figure out what negative 4 divided by 2 quantity squared is. What is negative 4 divided by 2? Negative 2. What is negative 2 quantity squared? Positive 4. We're going to add a 4 to both sides of the equation. So we get x squared minus 4x plus 4 equals positive 2. Bless you. What we have done, we completed the square. We made a perfect square trinomial on the left side, okay? What we started with, that was not a perfect square trinomial. And when you're using this method, again, if I say something important, you can always write it down in the margin. When I'm using this method, the goal is to create a perfect square trinomial. So when you divide everything by a, and then take whatever b divided by 2 quantity squared was and add it to both sides, on the left side, you created a perfect square trinomial, okay? This 2 on the right side, do not move it back over, okay? If you move that back over, you're not going to have a perfect square trinomial anymore. So remember, what's a perfect square trinomial? You got to have a trinomial. First term's got to be a perfect square. It is. The last term has to be a perfect square. It is. C must be positive. But just because those things are true does not make it a perfect square trinomial, right? You got to check the middle term. To do that, square root of the first term is x. Square root of the last term is 2. X times 2 is 2x. Doubled is 4x. If that's the middle term, regardless of the sign, it's a perfect square trinomial. So by doing this, b divided by 2 quantity squared, we created that. All right? Step 4 says, factor the perfect square trinomial using the shortcut method we learned earlier. So remember, if you have a perfect square trinomial, that means you're going to have 2 identical factors. So you make one set of parentheses and square it. The right side, you just bring it down. What's my sign going to be for the factor? Z. Y'all remember? It's whatever b is. Minus. What's the first term? X. How'd you get that? Square root of the first term, right? What is this last term? 2. Is it because of this 2 over on the right side? No, it's because it's the square root of the last term of the perfect square trinomial, right? So we just factored, imagine if we had to do all this work and then do the T-chart divide and slide on this. Okay, now if you forgot how to do the shortcut, you could still do T-chart and divide and slide. This is going to take you a whole lot more time. This problem's already long enough as it is. So it would behoove you to memorize the shortcut of factoring a perfect square trinomial. Okay, step 5, take the square root of both sides. Make sure to take the positive and negative square root of the right side. Okay, so we're going to take the square root of x minus 2 quantity squared. Take the square root of both sides, and it said on the right side, make sure you take the positive and negative. Don't put the plus and minus sign under the radical. It's outside of the radical. So we haven't actually taken the square root yet. We just wrote it, the square root sign. So what do y'all think the square root of x minus 2 quantity squared is? X minus 2 equals, what's the square root of 2? Is it a perfect square? No. Does it have any perfect square factors other than 1? No. So right now, I'm just going to leave it plus or minus the square root of 2. If I could simplify that radical, I would. In my final answer, I will turn it into a decimal. I'll leave it in radical form and in decimal form because you never know which one they're going to want. Okay? Example 6. Write 2 separate equations and solve each one for the variable. Okay. Why we're writing 2 is because the right side is equal to a positive 2. It's also equal to a negative 2. So in one of my equations, we're going to say x minus 2 equals the square root of 2. And in the other equation, we're going to say x minus 2 equals negative square root of 2. Okay? And then I'll solve each side. So on the left side, I'll add 2 to both sides. Can somebody get that, please? So I have x equals, can I add 2 to the 2 under the radical? No. Okay. So am I just going to write 2 square root 2? No, because that means 2 times the square root of 2. Okay. So I have to write 2 plus the square root of 2. And that might be how I leave my answer. If it says leave it in radical form, that's one of your solutions, okay? Over here, when I add 2 to both sides, now a lot of kids make the mistake, they'll do x minus 2 and x plus 2. You don't change that sign. You only thing that's changing is the sign of the square root of 2, okay? So that would be x equals 2 minus the square root of 2. So if I were graphing this, and I'm like, well, where is 2 plus the square root of 2 on the x-axis? I don't know. So if I were graphing this, or if they wanted it in decimal form, I would figure out what the square root of 2 is on my calculator. And the square root of 2 is approximately 1.4. So that's the same thing as 2 plus approximately 1.4. So x is approximately 3.4. So either this answer or this answer. If it's multiple choice and they leave it as 2 plus the square root of 2, then you got to be able to do that. Or if they leave it as a decimal, you got to be able to do that. So over here, that would be 2 minus approximately 1.4. So 2 minus 1.4 is approximately 0.6. So what I want you to do now is go back through your notes, check with your neighbors. Did you look at yours, compare each other's? Did you miss something that they wrote down that might be important? Do you want to write the steps down the left-hand column? Like brief steps, obviously not every single word that we wrote on the previous page. But what would be helpful to you when you come back to this problem? Is there something you want to highlight? Is there something that you want to make an important note about? But look at your neighbor's notes, look at yours. Do you need to add anything, delete anything, write some steps in? All up to you. And the video will be on Edmodo as well. Oh, or you might also see the answer. See how these are exactly the same in radical form except for one's plus the square root of 2, one's minus? You might see it as x equals 2 plus or minus the square root of 2. Or they combine it. That's two separate answers. Okay, it's 2 plus the square root of 2 and it's 2 minus the square root of 2, just written like as a combo. Somebody get that, please. Sorry, I got my video going. And I'm only going to do one more example, so for those of you that have been gone, after I do the next example, then you can go back and catch up on what you missed. So like me personally, I would probably make brief notes, and I should have written this up above, but I didn't. Next time, I'm learning. I would probably write ax squared plus bx equals c. Divide all terms by a. Complete the square. And if I had not written this there, it'd all be right next to it. But since I did that, I'm making arrows. Factor the PST, shortcut. Square root both sides. Square root positive negative square root of right side. Make two equations and solve. These are your notes. You do what's going to be useful for you when you go back and look because you've forgotten how to do it and you need help and you're trying to be self-sufficient. What's going to help you get through the problem? And right now we're not going to write anything at the bottom. We might put something down there next class when we go back and review our notes. Okay? So like I said, only have one more example. So if there's something you still want to do on this, when I get finished with the second example, you can come back to it. And if you already are finished, go ahead and do your little lines on the next page. What? Yeah, I'm just going to do one more and then you can come back and get the second one that while you're getting your pictures taken. Example 2. And our example is 2x squared minus 2x plus 3 equals 9. I wonder why they didn't do picture day on activity day. And I thought we already had picture day. That's what I thought. Club pictures. Oh, club pictures. Oh, gotcha. Okay, what's the first thing we do? Rewrite the equation in ax squared plus bx equals c. Now this has a constant on the left and a constant on the right. The last one didn't. If that happens, no problem. They're both constants. We can combine them. They're like terms. We need this one to be moved over to the right side. Okay? So we'll just subtract 3 from both sides. And that gives us 2x squared minus 2x equals 6. And a lot of times I kind of like to leave a little extra space for c because I know I've got to put a new constant there that creates a perfect square trinomial, and that kind of helps me remember, like, I should have 3 terms over here. I haven't created it yet, but I can't forget not to. What's the next thing I do? Divide all terms by a if a is not 1, and it is not, so I'll divide every term on both sides of the equation by a. So that leaves me with x squared minus x equals 3. Now what do we do? Complete the square, is that what you said? B divided by 2, quantity squared? Exactly. So that's the process is called completing the square. So we take, I do it over here on the side, b divided by 2, quantity squared. And are we using the original b? No. You might want to make yourself a little note. We are using what the b is of the quadratic we have right now. And what is b? Negative 1. We plug that in for b, substitute, divide by 2, and we square it. Now when we have a fraction, negative 1 does not divide by 2 evenly, and we do not want to create a decimal, okay? So don't stop working because it's a fraction. When I square negative 1/2, doesn't that mean negative 1/2 times negative 1/2? Isn't that what you do when you square it? And when we multiply fractions, we do numerator times numerator, denominator times denominator. So what is negative 1 times negative 1? Positive 1. What is 2 times 2? 4. So we have 1/4 that we're going to add to both sides. All right. So now we have x squared minus x plus 1/4 equals 3 plus 1/4. If I have 3 cups of sugar plus 1/4 a cup of sugar, isn't that 3 1/4 cups of sugar? And I probably don't want to leave it as a mixed number. I probably want to write it improper. Do y'all remember how to convert a mixed fraction to improper?
We do 4 times 3 plus 1.
Exactly, which is
12 plus 1 is 13, so
13/4. So I would probably leave that as improper for now. Okay? Now, you're thinking, this is supposed to be a perfect square trinomial that we just created, but there's a fraction there. Okay, but if we did this correctly, it's a perfect square trinomial. What is the square root of x squared? X. What's the square root of 1/4? 1/2. You know 1/2 times 1/2 gave you 1/4. Well, negative 1/2 times negative 1/2. So x times 1/2 is 1/2 x, and 1/2 x doubled is 2 over 2x, which reduces to what? 1x. Is that your middle term regardless of sign? So did we create a perfect square trinomial even though it was a factor? Yeah, we did. So as long as you did this right, then you made a perfect square trinomial. But if you're not sure, you could check it. Okay? So because it's a perfect square trinomial, we're going to factor it using the shortcut. So we know that means we have 2 factors that are identical. That's why we make one set of parentheses, but we square it. What's going to be the sign in parentheses? The negative sign. What's my first term? X. What is the square root of 1/4? 1/2. We know 1/2 times 1/2 gave us 1/4, so the square root of 1/4 is 1/2, right? Is everybody cool so far?